r with respect to theta is here, times sine of theta, plus r times cosine theta, over root of r with respect to theta is cosine times cosine, minus r times sine of theta. I know what theta equals pi over 3. I know all of you have them memorized, but just in case, I'll put this here, so that we know that cosine of pi over 3 is 1/2, sine of pi over 3 is root 3 over 2. So I replace each cosine and sine with their values. This multiplies is here. I distribute this. In the bottom, this squared is here. I distributed a -1 and that, so I got negative root 3 over 2. That becomes root 3, I'm sorry, 3 over 4. I then combine my like terms. This is root 3 over 4 plus root 3 over 4, which gives me 2 root 3 over 4, which reduces to root 3 over 2. My 1/2 stays the same. Down here, negative root 3 over 2 is here. 1/4 minus 3/4 is negative 2/4, which is minus 1/2. Factor out a -1 at the bottom, they're the same, you get -1. So what's the slope of the tangent line at theta equals pi over 3? -1. We're not even done. I want to ask you this. Looking at this graph here, which is what we're doing. And by the way, so as we look at this graph here, pi over 3 is what? 60 degrees. That's about right? You can see the slope of the tangent line really is -1. Right? It's a negative slope of the whole thing. So my question is, what is that point where it touches exactly there? This is an x, y coordinate. So we need to figure out what that x, y coordinate is, because what I want to do is I want to come up with the equation of the tangent line. And I need a point and slope. I got the slope. Now I need a point. There's my x coordinate. Would you please find my y coordinate?
That's actually kind of easy.
So now I have an x coordinate, a y coordinate. So whatever this decimal's approximations are, that's what this point is. And the slope of the tangent line there is -1. So if need be, I could come up with the equation of a line. We're getting a little low on time, so I'm not going to force you to work with those crazy numbers. But you could if you needed to, right? We're still going to base it off of this same graph here, but I want to find the points. Where's the tangent lines? Are horizontal and vertical. We can see that there are some horizontal tangents, some vertical tangents. All right, I'd like to look at the derivative. I'm going to clean that up here in just a second. As we look at that derivative, what is the slope of a line that is horizontal? 0. And what is the slope of a line that is vertical? It's undefined, right? The slope of the tangent line is this function here. The slope will be 0 when the numerator is equal to 0, and it will be undefined when the denominator is equal to 0. Does that make sense? So let's start here. Horizontal. So this is where cosine theta, sine theta, plus so obviously we have a little bit of work to do. Copy that right? No, this should be cosine. Let's get us to here. Now, I know that you all know how to solve an equation like this, but just in case one or two of you forgot, here's what we do. It's like in the beginning algebra, we factor it and we solve it. So each piece equal to 0. And this should be amusing. I will let you guys figure this out. We'll say only from 0 to 2 pi. So if you didn't get your storage tank problem back, make sure you get that. this out. You're my trig experts. Let's start here. Where's cosine going to be equal to 0? Right? Notice we got a weird dealing going on there. We'll handle that in a minute. How about there? Let's start here. Where is sine negative? What is 3 and 4? Luckily I have my handy dandy triangle here. What's the reference angle when sine is going to equal a half? 5 or 6. So what is the angle in quadrants 3 and 4?
7, 5, or 6.
Just take a minute, make sure your neighbor understands what's going on here.
I love trig stuff. I used to have a history exam thing. It's like running on 2 hours of sleep. Got up all sickness and early to get there, and she's like, "I'll do it next week." Nice. And I'm like, I had class with her all day. I had work all afternoon, and here I am. I'm like, I'm so ready to go to sleep. 2 hours of sleep right now. And like an 18-hour day on top of it. Yeah.
That high altitude is in the third quarter. I saw that we should take the exam together. Oh my god.
All right. Yeah. We're going to talk about that. We got to finish this before we talk about the other.
You forgot the theta. So it's cosine squared.
I sure did. All right. How do we solve an equation like this? Maybe we write it down.
Oh, cosine
Isn't it just 1 minus sine?
The denominator.
It's cosine squared minus sine squared,
The
isn't that
denominator is equal to 0.
1?
It's
So that's
undefined.
1 minus sine.
This is the numerator. Yep.
what? Because cosine squared is 1 minus sine squared of theta. So you just convert it into
Yeah.
We add both sides by sine and then multiply everything through by -1.
Say it again for me.
Add sine theta to both sides and then multiply through by -1.
Okay, let's try that.
right?
I'm not sure what that accomplishes.
No, I was trying to make it 1.
Can you sub in
Yeah, I was
1
trying to
minus
be sure.
sine squared of theta?
Sorry.
That's okay. We're trying to get creative here. You want to do what now?
Can you sub in like 1 minus sine squared of theta for cosine squared? Is that
1 minus sine squared theta for here?
Yeah.
Let's try it. Let's see what that gives us. It gives us negative 2 sine squared theta minus sine theta equals 0. I'm going to multiply through by negative 1 maybe. Plus minus where? Is our situation improved?
Yeah.
Maybe. Can I factor that?
Yeah.
I'm thinking we can factor this.
No.
Here, how about this? How would you solve that? Thinking something like that? So we already know the reference angle for sine is going to be pi over 6. What quadrants is sine positive in? 1 and 2, right? Where y is positive. Where's sine equal to negative 1? So we have an anomaly here. So what we would need to do, and I just don't have the strength to do it right now, is we would need to explore further what's going on at 3 pi over 2. We would actually need to take a limit and see what's happening as theta approaches 3 pi over 2 from either direction into that. We have to clean that up a little bit better. Do a limit, yeah.
Is it the corner, the little price there?
What? And we don't want to do it just by observation. We want to do it a little bit more analytically. So because we have something weird going on, we want to know what happens as theta approaches 3 pi over 2 into here. Is there a limit? So we'd have to apply L'Hopital's and a couple of other things going on with that. And what we would find out is that the limit would not exist. Meaning at 3 pi over 2, we're not going to have a vertical or a horizontal asymptote. We're going to have issues. Okay? So we're actually not going to include this. Alright, so let's explore the graph. I'm claiming that there's a horizontal asymptote at pi over 2, which we can see at the top is pi over 2. So, horizontal asymptote at pi over 2, which it certainly is. Horizontal asymptote at 7 pi over 6. That's there. See the angle there? 7 pi over 6. Also at 11 pi over 6. So the angle's coming this way. Okay. So it has to match the graph, right? And obviously at 3 pi over 2, something crazy is happening. Next up, the vertical asymptotes. It looks like we're going to have 2 of them. I lost it. It's wrong. Up here. It looks like at pi over 6, you should have a vertical asymptote. And at 5 pi
Yeah,
over
5 over
6,
6.
over here, I have another vertical asymptote. So the graph does jive with the information that we have. Or better. Any questions? Alright, we only went through one section today. 10.3. I thought it was, I didn't want to jump into another section right now. So that'll be it for today.